Okay, let's get started. Okay, hi folks. Hope you're all having a great day. Thanks for joining, and welcome to the 143rd episode of YFTT, Tech Talk by Engineers for Engineers. And I'm Anand Venkatesh. I lead products at Yugabyte. Today we have with us Krishna Sunder, our key lead engineer at Yugabyte. Hari will be sharing some insights into the common challenges faced in major Postgres database upgrades, and we will talk about how our new in place and online upgrade and rollback feature addresses some of these issues. There is a lot to cover today. So without further ado, let me hand it over to Hari. Over to you, Hari.
Thanks, Anand. And hey, everyone. I'm Hari. I'm a software engineer in Yugabyte. I've been here for like 3 years. Been working on databases for like 12, 13 years right now. And yeah, I'm usually work on the storage side of the DB, but also on the metadata side, which is why I've been working on upgrades, because we'll see that it's all metadata. It's all about metadata. And I'll get started in. We have a lot to cover, and it's a really limited time, so I'll just get started with the deep dive. Right? So this is going to be a really deep dive into how Yugabyte has now in place online major Postgres upgrades with the capability to roll back. Right? And let's get the agenda and we'll cover what Postgres natively supports today and why major upgrades in Postgres are such a hard thing, the solution that Yugabyte has come up with, and then how we make it simple for everyone to use, have a demo as well, and we'll have tons of time for Q&A at the end. Also, if you have any questions, somebody feel free to post it on YouTube or LinkedIn, and we'll be more than happy to answer those. All right, so right off, Postgres, everyone loves Postgres. We love Postgres here. One thing about Postgres is that it does not offer in-place online major updates. So each year, Postgres has a new release. Postgres, right now, it's 17. The next one is 18. It's coming up. And Postgres natively, when you go from one major release to another, it has to be, you can't do an online upgrade in place. Right. There are a few other alternatives that you can use. I'm not going to go too much into detail about this. There's tons of blogs and great posts about each of these options from everyone in the website. You can just go find them. So I'm not going to cover too much into each of these in detail. Just one thing to note is the other options are backup restore, blue-green or logical replication, and in-place offline. Just cover the cons with some of these approaches and backup restore. It's pretty simple. You take a backup and restore from old version to new version. It's going to be slow. It's going to take a long time, size of data, and you're going to need more storage. It's just a huge outage. So that's not preferred. And blue-green logical replication, you can go with get very little downtime, but it's not easy. You need twice the hardware. You need to have both sides running side by side. So you need to fix the hardware. It's actually very complex to pull off. There are, again, great instructions online. It's like a 20-step process to do it and do it correctly. And logical replication has its own limitations. There's like tons of things that you can't do with it. So it doesn't work for everyone. When it works great, it's nice, but it's not easy as well. And the third one is the most preferred go-to option is to do an in-place offline upgrade. And Postgres has a tool called PG Upgrade, and it's a native Postgres tool that helps you do this thing. The only caveat with that is it does have an outage. Now, depending on your database and schema and how you use it, it could be tens of minutes to 30 minutes, 1 hour, or even longer. You've heard people have multi-hour outages with PG Upgrade. So at Yugabyte, we have high availability as one of our main goals. And taking it offline for even 10 minutes isn't an option for us. So we wanted to come up with a better approach and do in-place online upgrade. And lastly, all of these approaches, there's no real way to roll back an upgrade. Right? Once you are on the new major Postgres version, that's it. There's no going back. You are going to be stuck with it. Right? It's very difficult to go backwards. And at Yugabyte, we have the option to do rollbacks, and we want to preserve that while you're doing major Postgres upgrades as well.
So, Ari, on that, like, are there any other? I know there are so many other Postgres database solutions out there. Does any of them offer close to this, like rollback, especially? Yeah.
Yeah, these three options are what's in there today. No one has, you can't do anything else. It's just a technical limitation. It can't be fixed without a solution that we had to build in Yugabyte. And not all vendors even have logical replication blue-green, right? Some of them just say you have to back up to store. So in place offline might not be an option too. So, but yeah, everyone else is sort of right now goes into one of these three buckets.
Got it.
And we'll see why that's actually happening, right? So I can go into the next slide. And yeah, so why is it so hard? What's so wrong? Right? The main culprit is the system catalog. The system catalog in Postgres is not backward compatible. And on every major release, this system catalog is changing with every release. And it's an architectural choice. It's not like it's just happening by itself. It's just people have made the conscious decision that we are going to do it this way. And we're going to keep this system catalog flexible enough to help with some other, it has some great benefits to it, but it does come as a downside that upgrades are hard. And this is just one of the problems. I'll go into the catalog in detail as well. There's other things like serialization format of other views and expressions, and the wall itself isn't backward compatible. So there's a ton of things. Like there's less explored options. People haven't done a full deep dive into what all is needed to fix it in Postgres, because the system catalog is the elephant in the room. Right? It's like so big that without solving that, you can't even get to the other problems. So what is the system catalog, right? What is this thing in Postgres? So a tidbit history lesson is that every database has a system catalog. Ingress, which is the precursor to Postgres, was the first database that actually brought in this notion of a system catalog. Before it was called information schema and system R and such. So the system catalog is just tables. They're like any other tables that you have in a database, but these are internal for use by the DB system itself. And it stores metadata. No data goes in there, it's just metadata only. And this is the metadata that the database system, Postgres, needs to be able to handle all the queries that people throw at it, right? There's around 60 odd tables. Again, this thing, the number changes from release to release. Right now it's something at 65. And so every time they're free to add new tables or more tables that are not in use. The one thing to know about these is they are hard-coded. The schema of these databases are hard-coded. You can't just go add a column and drop a column on the fly. It has to be strictly the same. And the PG code has it hard-coded in the code, in the C code of Postgres. The schema is literally hard-coded. Right? So it's very tightly coupled into the database system itself. I'll go into detail of why that's happening. And the other thing is the entire Postgres system needs to know it. Everyone needs to know metadata. When you take a backup, you need to know about it. When you run a select query, you need to know about it. Vacuum needs to know, analyze. Every component of Postgres has to know how to read and interpret the metadata. So it's just throughout the code base, right? And it's actually a good thing, right? So that's why every database, major database uses this, because it actually comes with a lot of great advantages, right? In Postgres, it gives you transaction DDLs, and it helps ease of development. Right? When you change this catalog schema, in the new code, you don't have to worry about the old schema versions. You don't have to if-else the entire code base saying, hey, if I have a 10 PG schema, what do I do? Versus if I have an 18 schema, what do I do? Right? A rough estimate is that there's at least 1,000 places in the code base where the schema is read and interpreted, possibly more. And to put if-else in all of those places just messes up the code base. Right? It's not going to be ideal to do that. So, but yeah, again, this is again high level. So I'll go a little bit into it and say, what is this thing? What is metadata? What are these statements, right? So to look at that, let's take a simple query. Select star from orders, right? You give this to Postgres, the parser is going to look at it and says, okay, select star from orders, all looks fine. You'll give it to the planner, right? The query planner. The query planner is like, okay, I need to get all the columns from orders. The first question it has is, what is this orders? Is it a table or a view? And for it to know that, it has to go to a table, internal catalog table called PG class. And PG class will tell us what this orders is. And once we know if it's a table, which in this case is probably is we need to know what the star is. The star is all the columns. So I have to go to the PG attributes and get all the columns for my orders table. And then you can keep going down, right? What are the types of these columns? So what is an integer? And our user-defined types, what do they mean? So those information are stored in the PG types table. Now, why is this hard-coded, right? The system catalog tables are hard-coded, right? Because the very first question, what is orders, is it a table of view? If you and I were to answer that question, what we do is we run this query, which is select OID and rel kind, which is going to tell me if it's a table or a view, or if it doesn't even exist, it'll tell me not found. From PG class, the name is orders, right? But when you run this, it's going to ask the same questions. What is PG class now? And because is it a view or a table? And what are its columns? Which leads to a loop, right? So to find out what PG class is, I have to go to PG class. So the very first time I boot up, I don't know what PG class is. So it's a chicken and egg problem, right? So that's what PG class. And these tables are self-referential, right? Because PG class will have a row about itself. The attributes table will have rows about the attributes of itself. And again, the types table has a similar thing. It has to know its own column type. So these are self-referential, so it has to be hard-coded so that you can like query them and use them. Which is why, so this is what makes it all so hard. It has to be hard-coded. It's all baked into the core code. So system catalog, it's a hard problem to solve. Now, stepping back, looking at Yugabyte, this will just basically do a high-level overview of what Yugabyte is in the context of the upgrade, right? So Yugabyte uses Postgres. So we use the upper half of Yugabyte is Postgres. We take the query layer, which consists of the parser, the analyzer, the query planner, statistics, and the execution engine itself. And as part of this also is the system catalog sort of is owned by the query layer, but it lives in the storage layer, right? Because it's tables. So it sort of comes in the middle. But Yugabyte, again, reuses the same system catalog because we are Postgres compatible. You can't be Postgres compatible if you don't have the Postgres system tables. So we reuse the system catalog, and we have the same problem. Right? So dipping into the Yugabyte architecture of this, so Yugabyte has two services. We break it up into masters and T servers. The T servers is where all the user data resides, and the YB master is metadata only control layer service, and this helps us like really like separation of concerns. Essentially, like do control and metadata level job in the master, and the user data, user queries all go to the T server. So which has its own great advantages. One of it is the upgrades. Right? And the master is again a RAF tablet. It's got its own RAF group. It's highly available. It's essentially one special system shard, right? Because the servers have all the user shards. So the system catalog resides in the master shard. The user tables are all in the T server, to say. Right? So, but what does this mean for the application? Right? Because that's internal Yugabyte, but if you look at it from an application level, your application is going to connect to the T servers, which is where the Postgres lives in. Masters do not run Postgres. They are internal YB only services. So the application never directly goes to the master. They only go to the T server, which is why your PG, Postmaster, and all the Postgres backends are running in. And they will go to the master leader to read and write the catalog, right? The system catalog. Also, even in Postgres, the system catalog is heavily cached. With Yugabyte, we have tiered caches on top of it. So you don't have to go to the master on every query. Once you cache it, it's going to be the same. Your table schema doesn't change. So after the first load from master to server, this sort of round trip doesn't happen. The app will just go work with the T server. And again, there's no Postgres on the master itself. And so this is how Yugabyte works. And this is the basic, right? This is an example with Yugabyte version 2024.2, which is based off of Postgres 11. And the latest version that's coming up, 2025.1, or the preview 2.25.1.0, is actually Postgres 15. So we'll use this example to show how you upgrade from 11 to 15. Right. So how do you do it? Right. I'll just cover the upgrade framework. And we call it an upgrade framework because it does more than upgrade. Postgres, beyond upgrade, this extension, the statistics, there's tons more to do it. We are wrapping it all up into this one sort of framework and giving you a single click or API or CLI option and the Aeon and Anywhere products. Or if you're open source and you're using YugabyteDB, it's baked into YugabyteDB. So all you have to do is a process restart and YugabyteDB will do all of it for you. You don't have to do anything beyond it. Right? So it's meant to be easy to use. How are we doing this? How do we make upgrades online? The key is that we are going to block TDLs. So we are going to put the system catalog into a read-only mode. Right? Do not update the system catalog while the upgrade is going on. There are some exceptions, like temporary tables and materialize view refresh, because DMLs, reads and write to user tables, a lot of time the DML, especially read queries, are using temp tables to do processing on it. And so we allow temp tables. Temp tables are fine. They're not global. They don't live past the connection. They're local to a node. So those are fine. Those we allow. And we do special handling with materialized views. So that way, the effect on the DMLs are like minimal. There's no effect on DMLs themselves. The only thing is we block TDLs or schemas.
However, while DDLs are blocked and upgrades going on, what happens if user performs DDL?
You will get an error. I have a demo where I'll show a DDL during the upgrade. It'll say you can't run a DDL during a YSQL major upgrade. You have to wait for the upgrade is done. Right? So it'll come back with a clean error. It's not going to be blocked. So when I say blocked, essentially it's going to fail. Right? We thought the option of failing versus blocking it for multiple minutes or hours isn't ideal, so we just fail it.
Got it.
So now, given that we are blocking the DDLs and putting the catalog in a read-only mode, it gives us the capability to actually have two catalogs, right? The PG11 catalog and create a semantically equivalent PG15 catalog. They'll not be the same bit for bit, and because the table schemas themselves are different, the contents in the tables are different, but it'll be the equivalent of what you get with like a dump and restore or logical duplication or PG upgrade. You all use the same principle of creating a new catalog based off the own logical schema. So logically, they'll be the same. Right? And we reuse PG upgrade. It just works with Yugabyte, so we just reuse PG upgrade to build the PG15 catalog and use that. I'll go into details step by step how it actually works. But the core thing is we were going to keep both catalogs running side by side in a read-only mode. Right? All right. So here's the same example from before, but the first step is we're going to upgrade the masters. So we're going to move the masters from 2024.2 to 25.1. Right? They're still going to have the PG11 version of catalog. Again, master doesn't have Postgres, it's storage only. The storage layer doesn't really care. It's a key value store. It knows VTs, heaps, LSMs. It doesn't care about schemas and other stuff. So it can host the PG11 catalog and everything's fine. The T servers are still running PG11. They get the PG11 catalog. Nothing's affected. Right? So now all the masters are on the new version. The next step is to create the PG15 catalog. So the first thing we do is put the PG11 catalog, lock it up for put it in read only. So T servers can only read it; they can't write to it anymore. And after this is where we have to do the Postgres stuff. And the Postgres, we have to create the PG15 catalog. And the way you do that with Postgres, we use all of the same tools. The first thing is something called an initDB tool, which creates your base catalog. It creates the empty tables. They're not really empty. They're like the equivalent of what you'd get on a fresh install. So they're like a clean state PG15 install. initDB, we run that, it gives you this. And then you have to run the PG upgrade. And PG upgrade, with typical Postgres, you have to stop the PG11. And when you run PG upgrade, it will start up 11 in a special mode, 15 in a special mode, and do whatever it has to do. Which might be that thing we have to tweak a little bit just to make sure that, because hey, you already have a PG11 running for you, you don't have to start and shut it down. Right? So we reuse the PG11 from any of these T servers, pull the catalog through PG upgrade, convert it to the PG15 equivalent, and push it into the master. Right? And with this, now we have a fully ready PG15 catalog. And both are put in read-only mode. And yes, now that you have both versions of catalog, we are going to do the rolling upgrade of the Postgres instances and T-server nodes. And we move them one at a time from 2024.2 to 2025.1. And we call this the mix mode because you can do this fast, you can do this slow. Typically, people take 3-5 minutes between nodes just to make sure things are fine. And so while you're doing it, you are in a mix mode where some nodes are running PG11, some are running PG15. The PG11 node is going to use the PG11 catalog, and the 15 node is going to use the PG15 catalog. And they're going to work the same way. It doesn't matter which one you're on, right? And both can run DML. So both can do user table inserts, updates, deletes. All of that is fine. So it doesn't matter which version you're on, which one you connect to. You can run user DMLs. You can run your workload. They're totally unaffected while this is going on.
At this point, does all the nodes are still serving DML or a specific one node serves and others? Okay,
Right.
awesome.
Yeah, I think that part I'm sort of hiding everything into one box saying T-server, but with Yugabyte, you have like Postgres on every node that your app connects to. They're connecting to all of that. The data itself is sharded and split among all three of them. So even if you connect to a PG11 node, you're getting data from the T-server 2 and 1, and same vice versa. So again, this thing is a very unique thing with Yugabyte, right? Because you have this mixed mode thing, and we do several optimizations when we push and pull things from different nodes, and that we have to do some special handling to make sure those are version compatible. If I have some time, I'll cover it, but I don't think I'll have enough time for it. But yeah, we'll blog about it at some point.
So literally, no downtime experience for users that way.
No,
The
no,
DMLs
yeah.
continue to, yeah, perfect.
Yep,
Okay.
yep.
There's a question from Frank. Is there a dry run mode with no upgrade but the same DDL restriction to validate the application? Will run well
That's a
during.
good option. That's like, if we don't have it today, we couldn't add it. I mean, we can just give you a G flag to do that. It's not too hard to do. But yeah, that is a great feedback. I think we can expose it very easily. Yeah.
Cool.
But yeah, it's not that way. Oh, again, I mean, if you want to do it, you can just. By the way, you can roll back, right? So you can run the upgrade. Don't finalize. Just roll it back right now if you want to do it. Really, you can. And I've done it for my demo, right? Because of course I've gotten it wrong. I have to do it myself. And yes, so upgrade all of your tablet servers to PG15. So once they're all on PG15, we call this the monitoring, right? You can be on this mode for however long you want. Only restriction is that you can't run DDLs. And you can evaluate your application, right? Everything's stable now. All the nodes are up. Nothing's going down. Everything's steady. So run your application at full blast. Make sure your queries are performing well, right? Major versions come with major changes in the Postgres code. Default query plans change. So lots of things. There is always chance for things to go back. Enterprises don't want to take risk, so they want to monitor it. And so we give you the option to run the full app, make sure the queries are performing, everything is fine, and only if you're ready to pull the plug, then you go and finalize the upgrade. Right? And finalize, it's simple. We just delete the PG11 catalog and allow writes to the PG15 catalog, and then you're done. Right? But say you don't like it. Something's wrong, some default queries off. For example, PG11 was like rounding down floats to 3 digits. 15 doesn't do that. But if your app has a dependence on it, then okay, you can roll back. And rolling back is easy. Just do whatever we did backwards and just go put all the T servers back on PG11. And now you're back on PG11 behavior. Right? If you want to fully roll back, well, okay, delete the PG15 catalog and roll back all the masters back to PG11. So it's just back where you started. And then you can try it all again. Right? So you can do this how many ever times you want to.
This is interesting, Hari. I had more questions to ask, but we are short of time. In the interest of time, I'll let you continue. Yeah.
Yeah, I'll do a demo. So we wrap it all into one API. So it's supposed to be simple. I'll skip that and I'll get to the demo part. And this is my demo. There you go. So I have a 3-node instance here, and it's just a local cluster. I'm not going to use the single API thing, right? Because I want to step through it step by step and show you that those 3-4 stages. So I'm going to do this all bare metal, just like command lines. no fancy tooling in here. So I have a 3-node local cluster and 3 T servers and 3 masters. We are running 2024.1, which is PG11, right? Then MySQL SH, and just do a select version. Select version. It's going to say 11.2. This is what 2024.2 is of. I'm going to start a simple app. This is like just a Java thing that does 30 TPS across these 3 nodes. Let it warm up. And it should be doing 30 queries on every node, give or take. It's not a fancy app. So it's like there's a little bit of drift to the nodes. But yeah, it's doing 30 queries. So and this is doing inserts. This is writing 30 rows per second, right? So now while this is running, first thing, of course, is to make sure that my database is compatible. So I'm going to run the PG upgrade check. This is a PG upgrade tool. Run it and check. Of course, my thing is compatible. It's a very simple app, so it's going to work. And I'm going to set this flag for making the T servers compatible. The mix mode expression pushed on that I mentioned. So I'm going to set that flag. Again, if you're using Yugabyte Anywhere or Yugabyte, they do this automatically for you. You don't have to do this step. So now that I have my flag and I'm on this folder, so I'm going to restart my masters first on the new version. Restart node 1 and just the master. So this is going to put the master 1 on 25.1. That's master 1. If I refresh, okay, this guy is now on 25.1. And by the way, it doesn't impact the app because the app doesn't connect to the masters at all. So there's no impact in that. And restart the other masters really quickly here. And the third one. So now all 3 masters are on the new version. I'm going to run the catalog update, right? And simple YB command, which is this update my version catalog. So this is going to go in and create the PG15 tables, the initDB, the PG upgrade, and all of that stuff. Right? And while it's running, it's going to take a few seconds to a minute or so. My application is still inserting 30 rows. There's nothing wrong in here. And I can actually go in and see it making progress, the catalog upgrade. So go to my master leader. If I just look at my logs, I should be able to see things like initDB, and there you go. It's just doing its thing of creating the initial tables. And if I actually go in here, I can show you both versions of the catalog. Right? I'm going to put something, a global table space actually. Typically, you'd only see one table space always on the template 1 database. Now you can see this template 1 has 2 table spaces, right? The same OID, 1, 2, and 3. But if you look really closely, the UID, there's something different in here. So the actual table has a 1 bit difference here. So this is the PG11 version of the table and the 15 version of the table. So if I go look at the schema, they'll be different. And let's see. Oh yeah, the upgrade is done. So the PG15 catalog is ready. So your question of what happens if we run a DDL, let's try that. C, let's do a create table 1 int and run that, and I get an error saying DDLs and catalog modifications not allowed. So now let's go upgrade. I'm going to upgrade 2 of the nodes to PG15, and I'm just kidding it. I'm just taking it down and restarting it. And of course, my app is going to hit it because there's no connection balancer. There's no smart driver in here. It's just Java using some default PG connections. Right? But it'll reconnect and it's back up at 30.
So it's back again. Yeah.
Yep. And if I go look at my version, let's start quick. And go. This should say PG15. The node 1 is 15, and node 3 should be on 11. Like node 3 is on 11, and 1 is on 15. And so this is the mix mode, and I'm still getting the same QPS. Everything's fine. So I can also roll back now if I want it. I'm going to upgrade and finalize. Right? So I'm going to upgrade my 3rd node. Of course, it's going to kill its own connections. And I'm just going to finalize, which again, it's a simple YB command that's going to say finalize upgrade. And done. And we're done. And now that I've finalized in the new catalog, if I actually go here, it should only be 1 table, right? So table space. There's only one right now, and it's the PG15 version of it. The Laban version is completely gone. So now I'm free to run DDLs again. Let's print that. And there you go. That's my table.
Awesome.
So that was the demo.
That's awesome. That was awesome, Ari. And it was so snappy. The whole immediate upgrade option, right? Amazing.
Sorry, I had to rush it because we were short on time, but yeah.
No, this is great demo and great presentation. Thanks, Ari. This is good.
Any other questions?
Yeah, I think that's it. No questions. Got it. Okay. Thanks, Ari. This is great.
Thank you, Anand.